bioavailability and risk-based framework for assessment of potentially toxic metals in soils. And as part of the work, this paper has been published in the peer-reviewed journal Scientific African on the title Bioavailability of Potentially Toxic Metals and Human Health Risk Assessment, Bibliometric Analysis and Review, and it's available online. So the introduction, why bioavailability matters in risk assessment. First of all, the Paracelsus principle states that the dose makes the poison. That means toxicity depends on the dose and not merely the presence of a particular metal, heavy metal. And as a result, there was a 4-step procedure established by the US EPA in risk assessment, which includes the hazard identification, dose response assessment, exposure assessment, and risk characterization. Soils are particularly potential sinks for these heavy metals when they are found in the environment. And children in particular are at a very high risk as compared to adults. So in this study, we designed a conceptual framework from soil to health risks that the risk estimates using the total concentration usually overestimate the risks, and only the bioaccessible to the bioavailable fraction can reach systemic circulation and cause toxicity. So as it is shown in the conceptual framework here, it shows that shows from the total concentration through the bioaccessible to the bioavailable, then the ones that can actually cause the health risks, then before you can characterize the risk. And once you do this characterization, considering bioavailability, you are able to really determine the actual cause of a particular risk from the heavy metals. So in the study, first of all, we look at the bibliometric analysis, systematic review, use the PRISMA framework, and also the voice viewer science mapping models over 66 studies structured around 6 objectives. Objective 1 was to construct and define the bioavailability as used in the literature. Then objective 2, look at a certain sample size and the preparation approaches. Objective 3, look at the bioaccessibility considering in vitro methods, bioavailability considering in vivo methods or animal models, and then their performance and their limitations, followed by the quality assurance and quality control procedures, then the methods of concern and the methods that were used and the factors that influence the bioavailability and accessibility. So through the method, we look at the search strategy and the analytical tools. The data sources were from Scopus database. Also, we use the LitMap, which is an AI generation tool to search through the internet and then come across and download all these papers that were used for the study using set terms such as bioavailability, bioaccessibility, hazard quotient, health risks, and all that. Then the peer review, look at English articles that were published. We look at from 1990, where there was an inception of risk assessment by the US EPA to now. So we look at a wider scope, and then we did the analytical pipeline where we use the PRISMA and then the Joanna Briggs Institute critical appraisal methods to examine the literature for their strengths and then included them thereafter. Then we did the data extraction to actually get to the results. So we identify about 149 papers, screen them, and then finally we included 66 studies. Looking at the study landscape, realized that most of the studies were from the United States, followed by Australia, China, Canada, and then UK, Spain, Belgium, Switzerland. And most of the studies uh, um, were published around 2013. However, the trend still increases from that 2013, and this is limited to the papers that we decided to include in our studies. So looking at the bibliometric analysis, we realized that we did a term and keyword concurrence, which revolve around 4 thematic clusters linking laboratory methods to risk assessment application. First of all, the arsenic bioaccessibility. Also look at the risk assessment or contaminant modeling, oral bioavailability, and then intestinal phase. All these were analysis that we did to look at the trends in the studies. Then we developed this construct of bioavailability, proving that from the total concentration, we should be focusing on looking at the bioavailable, which can really exert toxicity in humans, and not the total concentration, which could have several components adding up. So the selected in vitro procedures included the SBRC, PBET, IVG, RB, LP, UBM. All these are abbreviations for methods, and then their basis and their examples, and realize that these methods were strong or moderately strong and good for determining the bioaccessibility. Then with the animal studies, we also look at the use of mice, swine, rabbits, monkeys, and we realize that that one also produces results. However, the ethical issues and then the high cost involved with animal issues, animal studies, and the short dosing periods are also factors that we identified in the study, which in future we don't need to overlook. So we realized that the key factors that were influencing the bioavailability of potentially toxic metals or heavy metals in the soil included the soil physicochemical properties, the particle size, the chemical speciation, the physiological parameters, co-contaminant interaction, and some of these physical processes like aging of the soil and all that. So as a way of discussion, we look at the strengths, the weaknesses, the opportunities, threats, model to assess the papers and realize that most of the strengths, the study indicated that the rigorous Prisma and JDI criteria ensures transparency. Bibliometric marking reveals objective research trends. Then the strong in vitro, in vivo correlations also validate screening tools, and the interdisciplinary evidence spans the toxicology to public health. However, we realize that the weaknesses were that among the methods, we could not compare their findings because some of the methods produced varying results, which are not consistent to each other. And most studies in multi or metal-mixture interaction. Then the short dosing time was seen across most of the studies, and we believe that that one too cannot capture chronic exposure. Then we realized that as a way of opportunity in future, we could look at standardizing some protocols, developing hybrid models, and then building some frameworks to look at the mixture aspects. The threats included the ethical and cost issues, then sometimes the extrapolation of findings to other sciences were also overlooked. But the key limitations and the gaps included the lack of standardization, short-term exposure focus